Hello, in this video we will learn how to find the solution of equation in one variable by using bisection method. So the problem is simply like this. If we have a function in one dimension in one variable and it's equal to 0, means we have a root of a function. So the root function x is the root of function of x of fx here. And as an example, if we have x minus 1 over x equals to 0, so in this case we have x squared equals to 1, or we have x equals to 1 or x equals to minus 1. So they both are the root of a function of x minus 1 over x equals to 0. Another example, to find the root of x to the power of 3 plus 4x squared minus 10 equals to 0 in the boundary of 1 and 2 here. To find the solution numerically, we can use a lot of method. In this case, in this time, we will discuss the bisection method here. The idea of the bisection method is simply we have lower bound and the upper bound of the region where the root exists, and we simply cut half of the region and find the next iteration. So for example, like this, we have a lower bound of the region and the upper bound here, and the bisection is simply check the location of the real root of the function, in this case the root of function here, the black line. So the first step is to divide the region into half. So we have u3 is the midpoint between u1 and u2, and after that we do some calculation to find out in which region do we need to do the calculation. So after find the region which is in the right side here, we split the region into half again and we get u4, and after that we found that the left side of the u4 will be the region will be the next region to calculate, and then we find u5 and then u6 and then u7 and so on. So basically cut the region in half, but before we cut the region in half, make sure we find the region to do the calculation in the next step. So that's basically how the bisection method works, and simply like this one again. So let's go to the code here. Oh, before we go to the code, we need to find how do we decide the region for the next calculation, because once we split the region into half, the next step is to find which part we should calculate. Is it the left side or the right side? So how do we find it? Is by simply the multiplication. As you can see in this figure, u1 and u3, the multiplication of f as a function of u1 with fu2, sorry, fu3 is negative. fu1 here, fu3 here, so the multiplication of fu1 and fu3 is negative. Positive multiply with negative. But if we multiply it fu2 and fu3, it will be positive. So the next region to calculate is basically the location where the multiplication of function is negative. That's how we decide how we decide the region to calculate. Okay, let's go to the Fortran program here. And in this Fortran program, we have basically the initialization here. It's just a command. It's just a command to to make sure the user understand what we do in the program. So the first step is to initialize the variables and the parameters used. In this program, we use relative tolerance of 10 to the power of minus 4. Remember, we use the double precision, and we use the lower bound is 1 and the upper bound is 2, as we can see in the example here. 1 and 2. So the next is the variables we use in the calculation, and we also introduce the integer. So the first part is simply writing the introduction here, the rule finding with bisection and so on, and after that approximating the initial value of the upper and lower bound or lower limit of the function, and the first step is simply to check whether the bound we use is correct or not. So in this case, if fu1 multiplied with fu2 equals to or bigger than 0, means the root of function is not located between the lower bound and the upper bound. So if it happens, we stop the calculation immediately. So your initial value is invalid, the root is not located between the initial values. So once the checking is complete, and if it is okay, we can go to the next step here. The first step is to determine the midpoint u3, as we can see here, the u3, and store the temporary value of the midpoint. We use u3 temporary equals to u3. Then we do the calculation, and remember to put the counter here to find out how many iteration happen. So as we talked about before, before we calculate the next step or the next region in the iteration, we have to make sure we do the checking again. If the multiplication of function is negative, then that's the region we are going to calculate, but it is positive. But if it is positive, it's not the region we calculate. So here, if we do the calculation, if fu1 multiplied with fu3 less than 0, then the next midpoint will be between, as you can see, if u1 and fu3 negative, means the region will be the left side here, and the next midpoint will be here, right? So this is half of u1 and u3. So that's why we introduce here the upper bound. The new upper bound will be u3, right? Because the region will be the left side region here, and the midpoint of this region is simply the lower bound plus the upper bound divided by 2, right here. Or if the calculation in the right side equals less than 0, means we put the upper bound, or sorry, the lower bound of the calculation equals to u3, and the u2 still become the upper bound. So that's why the midpoint, the new midpoint, will be the old u3 plus the u2 divided by 2, right? And then we do the checking again to find out the tolerance, to find out the relative tolerance of the calculation. So if the absolute value of the old u3, the old midpoint divided minus the new midpoint divided by the old midpoint, if it is less than or equal to the relative tolerance we set in the beginning, means the calculation is converged. We can exit the calculation and store the result here. The U3 temporary equals to U3. And then by doing so, if the exit command is executed, we exit the do loop here and we go to the next part of the code here, writing the result. So in this program, we introduce the function fx, which is the function itself. So if you want to use this code for another function, just change this function fx and change the relative tolerance, and also change the lower bound and upper bound of the function here. So that's all of the video, and if you have any question, please comment please put your comment below, and see you next time.